Hello, how you doing? It's Mr. Do the Math here, and today we're going to solve quadratic equations, right? Solve quadratic equations, right? So we're going to talk about this word factor. Factor, as a noun, is the individual parts of a multiplication problem. So it's parts of a multiplication problem, right? So the factors multiply to give you a product. So, right? So, like you look at that example at the book on your paper, it's 3 times 4. Those are factors that give you a product, right? Then you have the process of factoring, right? When you factor, you're turning an expression into a multiplication problem, right? So you factor by dividing, like when you factor this out, when you factor this, you make this into multiplication, right? All right, so there are 3 factoring methods that we talked about, right? Method 1, GCF. GCF means what?
Greatest common factor.
Right, greatest common factor. So we're finding the biggest factors between multiple terms, right? Greatest common factor. Then we have DOS, which is what?
Oh, something.
Difference of
Squares.
right? Perfect squares. The difference of 2 squares are perfect squares, right? Denoted by a squared minus b squared, right? The difference of 2 perfect squares, right? And then we have MA, which is multiply add, right? We take the factors of A and C that add to give you the B term, the middle term, okay? So let's look at these first couple of examples, which are a review of what we've done before. Number one says 4x squared minus 20x, right? First thing we always want to look at when we're doing any math is the fact to see if we have a GCF first, right? So what method? This is a binomial, so it's either going to be a GCF or it's going to be difference of squares. All right. So what's the method to factor this?
Pull out 4x.
Huh?
GCF.
GCF, right? The GCF. What's the GCF here?
4x.
4x, right? So we're going to divide 4x for both of these terms, right? When we divide 4x for both of these terms, the 4x comes on the outside, and we get x, because we just left 4 divided by 4 is 1, x squared divided by x is x, and then we have 20x divided by 4, which is
5. Negative 5.
right, minus 5. Right? Cool. So we factor by GCF. Number 2, it says x squared minus 9. What's the method to factor this one?
Perfect or difference of squares.
Difference of 2 squares.
DOS, difference of 2 squares. Alright? So x squared is a perfect square, that's x and x. 9 is a perfect square, that's a trois. So, what would the answer be?
X minus 3 parentheses x plus 3.
X minus 3 times?
X plus 3.
Good. X plus 3. Alright? So we're just reviewing factoring before we go into solving. Alright, number 3. It says x squared plus 8x plus 12. Alright? How do we solve this? How do we factor this one?
Multiply add.
The middle number is always the result of the interaction between the outside numbers.
What are you saying?
I'm saying that you get the middle number by factoring the 2 on the outside.
Multiply add. Right.
Okay.
Right. Find the factors of 12 that will give you the middle number. Right? Ezekiel just wanted to backwards explain it. Alright? So what's the factors of 12 that give us 8?
6 and 2.
Alright? 6 plus 2. Positive 6, positive 2. Right? So then we write it as our 2 binomials. X plus 6, x plus 2. You remember that?
Oh no, what is that? That says 62, right? Oh, just make sure.
Yeah, it says 62. Alright? And then the last one. Let's look at the last one. Number 4. We have 2x squared plus 7x minus 15, right? All right. Again, can you find, is there a greatest common factor here?
No.
No. This is not a binomial, so there's no difference in squares. So we will use multiply add. So we're going to really multiply A and C, right? A is 2 times negative 15. So we got to find the factors of negative 30 that add to give you 7.
3 and 10.
3 and 10.
Negative
Good.
10.
Negative 10. Negative 10?
No.
Well, the 7 is positive. That means the big number has to be positive.
Oh, my bad.
10 and negative 3 are your factors. Good. So it'll be x plus 10, x minus 3, right? Now, in this particular case, a equals 2, right? A is bigger than 1. Therefore, we got to divide all of our factors by 2. Okay? So then we got this 10 divided by 2, so it'll be x plus 5 and 2x minus 3. That is our solution. So that's a review of factoring. That's what we spent a week reviewing, right? So we factor, right? Now what we're going to do is solve the equation, which means that we're going to be given an equation like so, right? And it's going to be set equal to 0. So you're going to find out what x equals. And with quadratics, like so, the x values are going to be the places where your graph crosses the x-axis, right? And so let's look at this new thing, right? It's called the zero product rule, right? It's the zero product rule, which basically means that these are multiplication, right? The zero product rule means that we're going to set these equal to 0. So like A times B. This would be A, that would be B. A times B equals 0 means that A equals 0 and B equals 0, right? So what happens is when I factor this and I have my, when I factor it down and I have my two binomials, I'll set them equal to 0 to solve for x at the end, and then we have our solution, okay? So now let's look at number 5? Number 5 says what? Does it say 2x plus 1 or something like that? Yeah. 2x plus 1 and what? X minus 7 equals 0, right? So 2x plus 1 is A, x minus 7 is B. Zero product rule means basically to solve for x, right? So we're going to set both of these equal to 0. So it'll be 2x plus 1 equals 0 and x minus 7 equals 0. All right? So now we're going to go all the way back to the beginning of algebra 1, right? How do we solve for x here?
Subtract 1.
Yeah, you subtract 1 to both sides. 2x equals negative 1. Then what?
Divide by 2.
Divide by 2. So then x equals negative 1/2. Right? That's that one. And then for the x minus 7 equals 0, what would I do?
Add 7.
You add 7 to both sides. So x equals positive 7. Alright, so notice when it's x minus 7, x equals 7. So it's the opposite, right? When you set it equal to 0 when you solve. So your solution is, so like this value, again, and like we'll talk about this more in the oncoming days, but x equals is also known as the solution. It's also known as the 0, right? Because again, when you set it equal to 0, this is what this is, right? So when you make x 7, 7 minus 7 equals 0. So it's the solution, it's the 0, and it's the x-intercept of a quadratic, right? All of these mean the same thing. Okay? Let's look at number 6. What does number 6 say?
4x plus 1 equals x squared minus 3x plus 7.
4x plus 1 equals x squared minus 3x plus 7, you said? All right, so the first thing you need to do here, is set all of this equal to 0, right? So what we want to do is we're going to move everything to one side of the equal sign. And the thing that we move, we're going to move this expression because we got more terms over here. All right, so we're going to move this 4x over and this 1 over, right? Again, that's our math stuff, right? So we'll subtract 4x to both sides, right? You writing this down? All right, so you're going to get 1 equals x squared minus 7x plus 7. right? And then you're going to move this 1 over, because again, we want to set the equation equal to 0. That's the first thing we want to do. Alright? So then we subtract 1 to both sides. We're going to get 0 equals x squared minus 7x plus 6. Okay? Now, why did I subtract 4x from the 3x? Because they're like terms. And I subtracted 1 from the 7 because they were like terms. Just so we're clear. Alright? Now that we have it equal to 0, then we can, number 2, factor. Right? So we got x squared minus 7x plus 6. What are our factors of 6 that add to give you negative 7?
6 and negative 6, negative 1.
Right? So if they add to be negative, but they multiply to be positive, both of these got to be both negative. So it's going to be negative 1 and negative 6. Very good. So we're going to get 0 equals x minus 1 and x minus 6. Okay? Now we factored it. Now it looks like this. A times B equals 0. Right? So we set the whole equation equal to 0. We factored it, and now we're going to solve. Right? By 0 product, setting everything equal to 0. So it'll be x minus 1 equals 0, and x minus 6 equals 0. Right? So this is the new step. This is what we learned or we reviewed. This is what we're doing now. We're setting equal to 0, we're going to solve. So what's the values for x? X equals what?
1 and 6.
Yeah. 1 and 6, right? Because he added 1 to both sides. X equals 1, and he added 6 to both sides. X equals 6, right? So that's your answer. X equals 1 and 6. Or x equals 1, x equals 6. Okay? Let's look at the next example. Somebody read it to me, please.
X plus 2 parentheses 3x plus 1 equals 8.
Equals 8. Alright? Is this 0 product rule? No. Right? So you can't set this equal to 8 and that equal to 8 and solve. You can't do that. What you got to do is you got to set this equation equal to 0. So in order to set this equal to 0, we're going to have to double distribute this, then move the 8 over, then set it equal to 0. Okay? Alright? So let's do the math. Alright? So we're going to double distribute bop and bop. X times 3x is 3x squared. X times 1 is x, right? Then you got 2 times 3x, which is 6x, and then 2 times 1, which is 2, equals 8. Okay? Now, we can simplify this and move this 8 over, right? When we move the 8 over, we're subtracting 8 to both sides, and we got this x, we got this 6 and 1, right? So we're gonna end up with 3x squared plus 7x minus 6. Everybody get that? Did everybody understand how I got negative 6?
Yeah.
Tell me how.
You subtract 8.
Yeah, subtracting 8 from 2. So this is how I got my 7, and my 6 came from subtracting 8 from both sides. 2 minus 8 is negative 6. So now we have our equation equal to 0. So we set equal to 0. Now we can factor. All right? So what's our factors of negative 18 that equal negative 6?
Shouldn't it be 7?
Equals 7. Say equals positive 7 too.
Negative 9, negative 2.
Say 9 and negative 2.
Yeah.
Y'all agree?
C.
All right, 9 and negative 2.
That's a 7.
9 and negative 2. Y'all agree with that? All right, cool. Because it's going to multiply, give you negative 18. And then you do the math to get you positive 7. So here we go. We got 9. We got x plus 9, x minus 2, right? Equals 0. Now, because 8 equals 3, though, we got to divide everything by 3, right? So that's going to end up being x plus 3, right? And 3x minus 2 equals 0. So that's your bottoms up situation. Alright, now we factored it completely. Alright, now we can solve for x. So it'll be x plus 3 equals 0, and 3x minus 2 equals 0. Alright, I'll wait for you all to tell me what the solution is. Yeah, Lucas.
-3, 2 over 3,
X equals -3,
and 2 over 3.
and x equals 2 over 3. 2 over 3 because we added 2 to both sides divided by 3. Alright, so everybody see that? Plus 2, 3x equals 2. Then divide by 3, x equals 2 over 3. Alright? We good so far? Yeah? Alright, read to me the last one. What does the last one say?
X squared plus 4x minus 50 plus 4x minus x squared.
Equals 4x minus x squared. Alright, cool. Alright, first things first, let's set it equal to 0. So let's work it out. Tell me what to do. No.
You subtract the 4x and x, you add the x squared.
Yeah. Alright. So we're gonna subtract 4x to both sides. Right? Those are gonna cancel because they're opposites. Right? So we got x squared minus 50 equals negative x squared. Then we're gonna add x squared to both sides. Which is gonna give us what?
X to the 4th.
2x squared minus 50 equals 0. Right? Huh? Yeah, that's for real.
Why would it not
1
be
times
4?
1 is 1.
It's
Ooh.
only with multiplication.
Yeah, that's why.
Is what?
So look, we're adding. Since we're adding, we don't do nothing to the powers. If we was multiplying this, it'd be x to the 4th. Right? But we're adding. Right? It's a good question. Okay? So now we have 2x squared minus 50 equals 0. The next thing we want to do is factor this. Right? Is this the difference of 2 squares?
No.
No?
Yeah,
Yeah?
No.
negative 25 or 25 to 25.
What about this 2 though? It's got to be both. Alright? So it's not the difference of 2 squares yet. So what can we do?
You can do
We can
multiple.
split it. What you going to split it by?
X squared.
X squared? 2?
Actually, 2. Yeah.
You going to divide everything by 2?
Yeah.
Alright? So divide everything by 2. So we factor 2 out. So that's going to leave us with x squared minus 25 equals... You could do this though. Right? You can't?
You guys,
Couldn't you do multiply add as well?
it's x.
And just do, it would be a negative 100 and 0.
X plus 5, x minus 5.
Yeah, plus and minus. Right? You talking up here?
No, you could do multiply add, so it'd be negative 100 and then 0, and then it'd be 10, negative 10, and it'd be 0.
Then you got to divide by 2. So you're going to still get there.
Yeah.
Yeah. This is quicker though. You don't have
Yeah.
to do the multiply.
Yeah.
Alright? So you get 2 equals x plus 5, x minus 5. Right? This is the difference of squares. Right?
Sure is.
So then you set everything equal to 0. So you got 2 equals 0, x plus 5 equals 0, x minus 5 equals 0. Alright? With the 2 equals 0, 2 don't equal 0, so you don't, that's extraneous, you don't need that. Right? But 2 plus 5 equals 0, x equals what? Good. X minus 5 equals 0, x equals what?
5.
5. Good. So your solution is x equals negative 5, x equals positive 5. Okay? So with solving, with factoring and solving, the first thing you want to do is make sure that it's set equal to 0. Make sure the equation is set equal to 0. Right? When it's not set equal to 0, you got to make it equal to 0. Just like this one, and this one. Right? After you set it equal to 0, then you can factor. You got 3 ways to factor. You got greatest common factor, difference of squares, and multiply and add. Right? And then after you factor, then you can set your A and C, you set what you factored equal to 0 apiece. right? Then solve. Okay? And again, these values here will be the places where your graph crosses the x-axis. So where you see this 5 and -5, that means your graph gonna cross at 5 and it's gonna cross at -5. Okay? And because this is A is positive, it's gonna be doing it this way. Something like that. Right? A parabola. That's what this is. Okay? So, have any more questions, comment below. Until next time, let's do the math. Out.